All right, if you could please take out your complex fractions worksheet from yesterday. I'd like to go over one of the problems from the worksheet. I'm going to go over number 9. And if there are any other questions that you have on the worksheet, please come to see me in the morning tomorrow, or feel free to stay after school on Wednesday. But you do need to make sure that if you have questions that you get them asked and answered. So again, your complex fractions worksheet, I'm looking at number 9 on the worksheet. And in number 9, we have a complex fraction that says 1 over 2x minus 5 minus 7 over 8x minus 20. And that's all over x over 2x minus 5. So I'm using method 2. And in method 2, that's where we're looking at all of the denominators, both on the numerator and in the denominator of the fraction. And we're trying to focus on getting a least common denominator out of those 3 fractions. So looking at the 2x minus 5, the 8x minus 20, and the 2x minus 5 in the denominator. So the first thing I'm noticing with this second fraction on the numerator, that 8x minus 20 needs to be in factored form, so we can take out a 4. And once you factor out the 4, it becomes 2x minus 5. So factored form, you have to factor for every least common denominator. So then our least common denominator, they all have the 2x minus 5 in common, so that's part of the least common denominator. And the 4 is also part of the least common denominator. So then the second method says that you're going to take the top of the fraction, and you're going to multiply it by the least common denominator, so you're multiplying it by 4 times 2x minus 5. You're also taking the denominator and multiplying that by the least common denominator, or kind of thinking of using the least common denominator with that fraction. So looking at my numerator, there is a 2x minus 5, but it needs a 4. So that means we need to multiply the top by 4. The second one has the least common denominator, so we don't need to do anything with that. So that top becomes 4 minus 7. And that would be over times 2x minus 5. And then on the bottom, again, it has the 2x minus 5, so it just needs the 4. So now that's 4x, and that's over 4 times 2x minus 5. So the least common denominators are the same. They cancel out. That's the reason I like to use method 2, because both denominators now on the top part and the bottom are the same. They can cancel. Doing a little subtraction here, 4 minus 7 makes negative 3. And then on the denominator, we have the 4x. So that should be a negative 3 and then over 4x for number 9. So again, if you have other questions, please feel free to see me Wednesday morning, or you can obviously stay after school Wednesday as well, and I can hopefully go over some of those questions with you. So today we're going to start solving equations. We've done a lot of algebra, simplifying these fractions, adding, subtracting the fractions, multiplying, dividing the fractions. And then we're going to take all those concepts and try and use that in order to solve the equations. So in your notes packet, if you can turn to page 23, it's the last section, section 8.6. So this would be the last part of working through the rational functions, trying to solve rational equations. And we will spend 2 days on this, so we'll work on some of the problems today, and then we'll also go over some on Wednesday as well. So again, section 8.6, page 23. All right, so solving rational equations, we have 2 vocab terms. The one should be familiar. The first one says cross-multiplying. Cross-multiplying is just a method used to solve a rational equation when each side of the equation is a single expression. So think of a proportion, one thing is equal to another thing, so we cross multiply to solve. The second term, extraneous solution, we just used this when we were solving logarithmic equations. We also used it with absolute value equations. An extraneous solution is a solution that does not hold true when substituted back into the original problem. Or the original equation. In our case, because we have fractions, our denominator cannot equal 0. So that's when you're looking for an extraneous solution. If you have a number that makes the denominator 0, then it's an extraneous solution. So you will be focusing on your solution, checking it in the denominator of the fraction. If it is 0, then that part would be extraneous. So the first two examples we have would be the cross-multiplying examples. And cross-multiplying means you're going from the top of one diagonal to the bottom of the other fraction. So in this case, we would have 20 times x minus 2. Then you place your equal sign because you did the one side of the cross. And now we need to do the other side, going across or diagonal. We have the 5 times 2x minus 5. So you shouldn't have a fraction left over. You still need to have the equal sign because it's still an equation. We're just multiplying diagonal from top of the first to the bottom of the second. And then you're solving the equation that you have left. So multiply the 20 through. Multiply the 5 through. And then continue to solve, isolating the x. So I would add 40 and subtract the 10x. Make sure you're reducing. 15 over 10 becomes 5 halves. And then don't forget to check. So you have this solution, we need to check it back into the original problem. And that means we want to really place it in the denominator. So if we have 20, and then we're taking 2 times 5 halves minus 5, that's equal to 5 over 5 halves minus 2. And check it back into that original problem. So on the left side we have 20, and then 2 times 5 halves is 5. We get 5 minus 5, that's where I get a 0 in the denominator. And that cannot happen. So you have that fraction of 5 halves, and it actually is not a solution. So in this case, this is extraneous. That was the only solution. Therefore, this problem does not have a solution, because the one answer we found to be 5 halves, but if we check it back into the original problem, it makes the denominator 0, so it's not a solution. So looking at letter B, doing exactly the same steps as we did for letter A, using the cross multiplication. So going across top to the next bottom, we have 4 times x plus 5. And then the same thing, these two are both two-term binomials here. They need to be FOILed together. So x minus 1 times x plus 1. So multiply the 4 through, FOIL the x minus 1 times x plus 1, and that becomes x squared minus 1. Once you have an x squared term in the problem, you need to get everything to be with that x squared term. So subtract the 4x and also subtract 20. So that gives us a negative 21. And everybody's favorite thing to do at this point, we've done so much of it, factoring. We've got a negative 21, a negative 7, and a positive 3 would make a negative 4. Because the first term is a 1 in front of that x squared, we can just plug those in as a negative 7 and a 3. So one solution is positive 7, the other solution is negative 3. And then just do a quick check. So 7 plus 1 is good, 7 plus 5 is okay, plugging that into the denominator. Negative 3 plus 1 and negative 3 plus 5. Neither of those make the denominator negative, or I'm sorry, 0, so then they would be our solutions. So there are two problems underneath. See if you can do those two problems in the independent practice. Make sure you check your solutions. Again, make sure you're cross multiplying. I'm just going to start these two and then I'll give you the solution. So for the independent practice, the first one, you should end up with a negative 4. And then in the second one would be a negative 5. So make sure that you are getting those two solutions. I started it up here if you wanted to take a peek, cross multiplying and then getting everything by itself. The x's on one side, the number on the other, no factoring necessary in those two problems. All right, so if you flip the page, we are now going to try and solve a rational equation using the least common denominator. So now you're not going to have one term on the left and another term on the right, or one expression on the left and another on the right. Instead, we're going to have 3 or 4 pieces, like multiple terms on the left and the right. So this one says we're going to multiply each side by the least common denominator. So we're still using the least common denominator fact in order to help us solve this equation. And our goal is actually going to be to get rid of the fractions, just like cross multiplying. So when you cross multiply, you eliminate the fraction from the problem. If we look at this and try and use the least common denominator, we will also then eliminate the fraction from the problem. And I'm going to take you step by step through this so that you can kind of see what's going on with these. So the first thing, looking at the denominators, we need to get a least common denominator, just as if we were adding two fractions together. So we have a 3 in the denominator, and there's also an x, so that would be the least common denominator. So what we're going to do, it says multiply each side by the least common denominator. So we're going to take the left side and multiply it by the least common denominator. And I'm going to make it a fraction just so we're looking at fractions all together. And then I'm also going to multiply the right side by the least common denominator. So I'm going to take this step by step just so you see what's happening with the problem. We're literally distributing 3x to each term on the left and 3x to the term on the right. So I'm going to write this out. We have 3x over 1 times 8 over x. I'm not going to actually do the multiplication yet. I'm just showing you how this is working. The next one, we would have the 3x. That's my least common denominator. I'm multiplying that by 11/3. And then on the right, we have, again, the 3x, so my least common denominator times what's there, negative 14 over x. So this is like the expanded form. I'm going to show you how this works. You don't have to do this step every time, but just so you get an idea. So looking at this first piece, if anything can reduce or cancel, you want to do that to the problem. And there is an x on the top and an x on the bottom. Those x's will cancel, and we just have 3 times 8, which is 24. So by using the least common denominator, the denominator that was currently there cancels from our problem. And then we have the plus sign. Looking at the next piece, again, anything that's the same can cancel from the numerator and the denominator, and this would be the 3. So it was 3x times 11/3, but the 3 on the top can cancel with the 3 on the bottom, leaving us just with 11x. So now, on the left side, we don't have a fraction, which is our goal. So cross-multiplying got rid of the fractions. Using the least common denominator also gets rid of the fractions. Now looking at the last one on the right side, again, there's an x. We want to cancel out the x that it has in common in the denominator, and we're left with 3 times negative 14, which is negative 42. So now we just have this linear equation. We can get all the x's on one side, the numbers on the other, so we would have to subtract 24, which gives us a negative 66. And then when you divide by 11, you get negative 6. Again, reminder here, check your answer into the original equation. So look to see that negative 6 goes underneath the 8. 8 divided by negative 6 is okay. And then negative 6 over negative 14 over negative 6, again, that works for us. So negative 6 will be the solution. So we're going to try and use the same exact method for the third example underneath here. So we're going to look for the least common denominator. This 2 really we can place over 1. Make sure that your denominators are in factored form. If they're not, you have to factor it. Now both of these are already factored for us. So looking at the least common denominator, the first piece we see on the left there is an x plus 3. That part is also on the right, so that has to be part of the least common denominator. And then another factor is x minus 4. So that would be our least common denominator. So we're multiplying both sides by the least common denominator. So the right, we're multiplying by x plus 3 times x minus 4. Again, I'm just placing that over 1 so that we have all fractions in the problem. And then on the right side, we're multiplying that by x plus 3 and x minus 4, placing that over 1. So I'm going to write this out again step by step. Some of you might be able to skip this step if you kind of see what's happening with the problem. But we're taking the least common denominator and multiplying it by the fraction that's currently there. So x plus 3, x minus 4, that's my least common denominator, over 1, times the fraction 3x minus 5, x plus 3. And I'm just putting parentheses around each of those as well. That's equal to the least common denominator times the 2, so x plus 3, x minus 4, that's my least common denominator, times 2, which was part of the problem already. And then again, my least common denominator, x plus 3, x minus 4, times the problem that was there, or the piece that was already there, which was 18, x plus 3, x minus 4. So in each one of these, again, I have the least common denominator times the piece of the fraction that was already in the problem. So our goal is to eliminate the denominator by using the least common denominator in the problem. So now if you look at each piece, cancel, you're now multiplying. So think of this as like this is now a multiplication problem. You're just taking those two terms and multiplying them together. Well, if we were simplifying, we would cancel out any piece that's the same. And in the left one, that x plus 3 would be the same. So then whatever is left, we need to multiply together. So we have x minus 4 times 3x minus 5. So foiling that, we have 3x squared, and then a negative 5x and a negative 12x makes a negative 17x. Negative 4 and negative 5 multiplying gives us 20. So foiling together the pieces that are left, because now our goal is to solve. We're not just simplifying, but we're also solving. Looking at the middle two pieces, they're both over 1. So we can't really cancel anything out because they both are over 1. And that means we just need to multiply those together. So we're taking x plus 3 times x minus 4. Well, if we FOIL that, that gives us x squared minus x minus 12. All of that's supposed to be multiplied by 2 because it says times 2. So 2x squared minus 2x and then minus 24. So we're canceling the denominator part and then multiplying or foiling the numerator so that we can solve it. The last two terms here that we're looking at, the last two pieces that are being multiplied together, looking at their numerator, it has an x plus 3, well there's an x plus 3 in the denominator. And the first numerator has an x minus 4, well there's also an x minus 4 in that denominator. So the only thing that's left is an 18, and it has a plus sign in front of it, so it would be a positive 18. So the denominator cancels. You're multiplying the remaining numerator together. And in that third case, the only thing that was remaining was the 18. So now there are x squareds in the problem. There are x's, we've got numbers. We want to take everything to one side of the equation, set it equal to 0 so that we can solve. So our goal in these are to be solving for x. So we simplified, and then we multiplied the remaining numerator, and now we want to get things on one side so that it's equal to 0. So we would subtract 2x squared, add 2x, add a 24, and subtract an 18. And this gives us x squared minus 15x, and then plus 26. So 20 and 24, and then minus the 18. Or you could say 24 minus 18 is the 6 that adds on to the 20. So now we're factoring because we have an x squared. So 26 is the number we're factoring with. That would be a negative 2 and a negative 13, both negative to make positive 26. Again, we just have an x squared term. There's a 1 in the front, so those two pieces can become our factors. And then set this up and solve. So x is equal to 2 and x is equal to negative or positive 13. Don't forget to do a mental check. Plug them back into the denominator. Make sure it doesn't make the denominator equal to 0. So 2 plus 3 is okay. 2 minus 4 is still not 0. Plugging in the 13. 13 plus 3, 13 minus 4, not making the denominator equal to 0. So both of these would be our solutions. So there are two final problems at the bottom with the independent practice. Again, it says to solve by using the least common denominator, check for any extraneous solutions. So I'd like you to work on finishing these two problems. I'm going to give you the answers or also start the problem with you. And then any remaining time in class you can work on your homework. So again, I'm starting the problem. You can kind of work ahead, but the first step would be to think about the least common denominator. So you're using the least common denominator, which is 4x. You're multiplying the left by 4x. You're multiplying the right by 4x. if you need to write it out in the expanded form, feel free to do so. You could also stop doing that if you feel comfortable using the least common denominator. And I'm writing it out just in case. You've got that least common denominator times the piece that's already in the fraction. And then you're canceling or reducing. So the first one, x is equal to 2. Again, work yourself through the problem. The solution is up here if you want to take a peek. Make sure you cancel out the terms that are in common, multiply whatever is left in the numerator. You should have nothing in the denominator because those pieces are canceling from the problem. So with number 2, you should have two solutions as a positive 6 and a negative 3. I did not do the whole problem up here, so make sure you have the whole problem complete. I have most of it up here. I didn't do the final couple of steps. So tomorrow, we will continue solving these equations. We're going to look at denominators that need to be factored. And we'll just continue working through finding the least common denominator and using this same method, the same process, to solve the rational equations. Remember, make sure you're checking the answers you have into the denominator. Make sure that you check to see that it's not making an extraneous solution because it's making the denominator equal to 0. So your homework for today would be practice 8.6. We're doing side A, and you're going to do problems 1 through 16, and you're going to stop at 16. So practice A, 1 through 16. You'll look on the back then, and there's another practice, and that's what we'll be working on tomorrow. The solutions are also going to be distributed to you for both practice worksheets. The top has the solutions to A, the bottom has the solutions to B, and then the back has the solutions to the review, which we'll be working on at the end of the week. So again, 1 through 16 would be your homework on practice A. So side A, it says page 63 at the bottom.